as you can see it, we have the electric motor. This is a DC motor, and we have a fan here to cool the electric motor. And you can see the flywheel. This is the flywheel, and we connected these starting coil to it, so that whenever this here is going to make it to generate it's going to generate some a little bit of electricity from the system. And this is our alternator. So this is a 2900 watts alternator which we used, and it generates electricity from it too. So this section right here, this is where we have you can see this is a PC fan. This is where we have our charging system. This is where the transformer is, and right here we have our terminal. So this is connected to a car battery, a 12-volt car battery of maybe 100 amp to maybe 200 amp should be able to do the work. So the aim is to be able to spin this DC motor right here. This DC motor serves as the prime mover which rotates the alternator. What the alternator needs is to be able to spin and in turn generate up to like 220 volts to around 100 volts worth of power, and we can use that power to be able to power that things, and also use it to be able to, it supplies DC current to this transformer right here. Because if you take a look at the back, you can see it's exposed. Okay, the back is exposed. Let's take it there. You can see the back is exposed, and here we have our rectifying diode. The code is KBPC3510. Fine. With them, there's a big transformer in there. We have two transformer in there, and we have a PC fan right here. So what it does is to be able to cool the transformer inside the charging system so as to be able to charge the battery, and it charges the battery through these terminals right here. And if you look at it, this is for it to be able to work. And so this one is a 12 volts DC motor, which is also the prime mover. So it's made to spin the alternator. So this is a 2900 watts alternator. And if you take a look at this the flywheel right here, you notice this black, this side you see right here, this is where we have a magnet. So whenever this magnet move past through this starting coil, it generates a kind of current from the system, which we can use to power other lightings on the generator. So we used this leather right here as a way of making it to be flexible, so that whenever it's spinning the alternator right here, it's not going to start wobbling or vibrating. So we connected this fan here so as to, the aim of this fan is to suck air from this DC motor. Remember, this is a 12-volt DC motor. I think around 1 horsepower actually, though I would have recommended to use something much more than that. If you can use 2 horsepower worth of electric motor, that would do the work. So but this is 1 horsepower, and we connected it to the terminal right here, which will be connected to a battery. And the aim is for it to be able to spin the alternator nicely. And this alternator, some people, they say this is a 3000 watts alternator. Some do say it's 2900. So guys, this is how the charging system looks like. It has a PC fan right there. It is being powered by 12 volts power coming from the alternator. So what it does is, when the alternator generates the this is how the back of the of the alternator looks like. Once it generates electricity, so what we do is to tap in current from the line, from the power line, which is this, from the live and the neutral. It goes straight to the charging system, and once it goes straight to the charging system, it activates the PC fan right there, which cools the big transformers inside. So the big transformers inside, they're about two. One of them is around 30 volts. The other one is of DC watt of power, and the other one is around 12 volts. So they are both connected in series to give us high voltage, so that we can use it effectively to charge the battery that is powering the DC motor right here. So guys, I tested it and it worked to some extent. I noticed it was able to last for about 20 minutes. It was charging the battery for about 20 minutes with this charging system right here. So it's charged for about 20 minutes and it worked. But I noticed after 20 minutes, the battery started getting discharged. So that's why I'm going to be making a brand new one, a brand new furnace generator, which is going to be very powerful. Though we're going to be using a 12 volt motor, and we're going to be using a smaller alternator so that we're going to get maximum power. Hello, my friend, Rising Phoenix 7. Thanks for joining in. Yeah, so we're going to be connecting an alternator of around 1000 watts alternator. This one is 2800 watts. So we're going to be connecting the one of about 1000 watts. So since this one is 2800 watts of alternator, the power, I notice there's a little bit of lag. Anytime this motor is spinning this alternator, it has to roll a little bit of there's a delay before it starts generating electricity. So what I want to do is to reduce this 2900 watts alternator, is to reduce it to a 1000 watts alternator, which is the one you guys know, which is called I Pass My Neighbor alternator. This one should be able to spin it freely and generate current from it. And so I'm going to be building a new one. And if you take a look at the frame of this one, I used wood to be able to get the system running. I used wood to make this one. And the new one, I'm going to be using a generator frame. I'm going to be mounting the alternator on it. Not just mounting the alternator on it, but going to be mounting the electric motor too also on it, so that the system is going to run freely. So this is how it is. So guys, if you take a look at the inside, you see I used two big nuts in there to hold this leather right here, and this leather helps so that it doesn't wobble. So the system works for about 20 minutes. That was when it started discharging. So what I did was to connect a multimeter to it, and the current was stable. It was even higher than the battery. One thing you need to know is that whenever you're charging the system, you need to make sure that the voltage or the current that is being produced from this charger right here should be more than enough to charge the 12 volt battery, which will be able to power the electric motor, because it's doing more than one task at the same time. Powering this electric motor, and it's also carrying load, which is your lights and other things, and this charging system is trying to charge it at the same time. Sometimes it's not easy. That's why we need high voltage architecture to be able to do the charging effectively. Hello Joe, thanks so much for tuning in. Thanks for coming in, really appreciate. Yeah, so guys, I'm going to be making a brand new furnace generator. So most of the problems or most of the issues that I'm having from this one, I'm going to try to correct it on the other one. So the other one, we're not going to be using a wooden casing. We're going to be using a generator casing. How are you doing, Joe? And how are you doing, Rising Phoenix 7? Hope you guys are doing great. So guys, I'm going to be using a metal frame to do the other one. It's going to be solid, and you can see I used the generator starter to be able to mount the DC motor right here. And this DC motor is very powerful. I got this DC motor from a vehicle radiator fan. So this is a vehicle radiator fan. So I got it from there, and it has been working well. So I connected this fan to it so that what this one does is to suck air from, if you take a look